Okay, welcome back to Z Lessons, where we are going to look at Theorem 6 of our playlist dealing with circle theorems. In the previous video, we looked at this theorem, okay? But for today, we are going to go to Theorem 6. If you're wondering where to get this PDF book that we published at Z Lessons, specifically for these videos, check the link in the description below and you'll be able to download that book for free. Now, Theorem 6 says that angles subtended by an arc in the same segment are equal. If you're wondering what it means by subtended, I have a definition for you right here. It says that an angle subtended by an arc is an angle made where two lines from the ends of the arc meet. As you can see, we have the end of the arc, which is here, and another end here. This is the arc right here. This is the end and that's the end. Now we have two lines. As you can see, this line and this other line meet. So therefore this is what they mean by angle subtended by the arc. So that's what I mean. So let us go to GeoGebra and I'll show you what we are talking about. Okay, so this is what we learned last time. Okay, as you can see, this dotted line here is the arc, and we have the end points C and B, and as you can see, they meet at A, and therefore this is the angle subtended by this dotted arc. So that's what they mean. So now today we are learning this theorem, and as you can see, we have points that we can use from that previous lesson. So we're just going to use these points in order to speed up the lesson. Okay, that's all we need. All we need is an arc and two lines. So what do they mean when they say angles subtended by an arc in the same segment? Remember, in the former videos we looked at what we said is the segment. As you can see, it's talking about same segment here. Okay, so the segment is just an area bounded by a chord and an arc, as you can see. So that's what we call the segment. So let me just highlight this so that you can see it. So there it is. So that's the segment. As you can see, it's an area bounded by this dotted line representing the arc, and this let me just add a red, this red line, which is the chord. So this is the segment. So now the theorem is saying that the angles formed in the same segment are equal. So let us create some angles. As you can see, let us add this angle like so. Then let us add another angle like so. As you can see, these angles are in the same segment. Then we are going to measure them. So let us measure them. Let's measure angle ADB. And what is it giving us? It's giving us 93.3. Let us also measure angle CEB. And as you can see, it also giving us what? 93.3. So this is basically what the theorem says. So no matter how I move it, as long as it's in the same segment, it's going to maintain the same value, as you can see. Even as I adjust it, as you can see, when I adjust it, as long as they're in the same segment, they are always going to be equal angles. So that's what it means when they say angles in the same segment. So as you can see, that's it. That's the theorem. Same segment. No matter how I shrink them, this is 23.4, this is 23.4, as long as they're in the same segment. So there you have it. This is the theorem. So let me create a scenario whereby in the exam they can ask you to find something like so. Okay, then in the exam they tell you that find D. So how in the world are you going to find D like so? Very simple. All you have to do is identify this is a chord, not so, and this chord has two lines, this line and this line, and they are forming an angle here. This angle that is E is also originating from the same chord. So when you see and discover that an angle that is given, as you can see, this is a given angle, it is originating from this chord, and this unknown angle that we are told to find is also originating from this chord, which means that they are in the same what? Segment. As long as they are in the same segment, it means they are equal. So by just seeing this, as you can see, if this was 71.4 and we're told to find D, it's automatically going to be 71.4 because they're in the same segment. And when we measure them, we're going to find that it's going to be what? 71.4. So that's how examination questions come. You should be very careful to identify such properties. So therefore, my friends, this marks the end of this video. I know it was short, but I don't want to make it bigger than it should be. So that's it. If you're new to this channel, consider subscribing, because that, my friend, will mean that you're never gonna miss any of our uploaded videos, and you'll be caught on in whatever that we have to offer to you. Thank you so much. Until next time, have a nice day.